So type 2 error. Now type 2 error arises again. Let me just put things in context. You kindly see the type 1 video also. I've explained there what an error is. So what you have is you can imagine that for certain trials, if they come below critical value, you accept H naught. Suppose the setup is that, and here you reject H naught. So it's above the critical, you're rejecting it. Now your type 2 errors, you accept your H naught even though when it's false. So your probability of type 2 error is probability of you that you accept H naught, given that there's a true distribution which is there. You have the alternative with the alternative hypothesis being true. With the alternative hypothesis being true. So this is what we need to do. So basically here, so in type 1 error, you found the area of the black region. Here you need to find the area of the white region with a new mean. Just remember that. So it will become easier for you to do. So now the different types I've taken. I've taken some with normal distribution. In normal distribution, I have a variation of this is one tail test. I've taken normal distribution. This is the example of normal distribution with two tail test. This is I've taken a binomial distribution, and this is Poisson distribution. Now, binomial and Poisson can also have two tailed, so you find each region separately and work it out, basically. So let's start. So let's do the normal distribution, type 2 error. To begin with, I'll draw a small sketch. It's a normal distribution. Your sample size is 10. Whenever you work with sample, you have to apply the central limit theorem. What does the central limit theorem states that? The central limit states that the sample mean follows the normal distribution no matter whether the oriental distribution is normal or not, but the means will follow normal distribution with mean as mu and variance as sigma square over n. Now, when I say variance is sigma square upon n, my standard deviation will be sigma upon root n. So this is useful when you put in the calculator. So critical region is x bar is less than 56. So this is my critical region. X bar is less than 56. My true mean is 58.1. So your probability of type 2 error is you probability you accept H naught. So you'll accept H naught if you look at the diagram. When will you accept H naught? You'll accept it. That's a probability of finding that when your sample mean is greater than 56, given that you have a true mean. So you'll be using the true mean and not the H naught, not 61. You won't be using 61. Remember, in type 1 error, we use this. In type 2 error, you have to use the true mean. So then you simply use your calculator and just find this out. That's your probability of type 2 error. So what you need to do is you go to distribution, normal distribution, NCD, lower 56. Remember, it's a continuous distribution, so I don't have to take 57. For binomial and Poisson, you have to do that. Upper is 10 is to 10. Standard deviation. So your standard deviation, your variance is 7 square. So standard deviation is 7. So 7 divided by root root of n. Root of n is root 10. Your sample size is 10. Correct? And your mean is 58.1. I have to use the true mean. So find that out. 0.829. So that's your probability of making a type 2 error. That's what you need to remember. If they ask you in the same sum, what is the probability of type 1 error? What will you do? For type 1 error, for the same sum, if you ask to find, you will find probability that your x is less than 56, given that the mean is 61. That will give you a type 1 error. So that's how you will be doing. Simple as that. Now, two-tail test. So what you do in the two-tail test? You have your critical regions are given. Okay. This is 9. This is 16. So less than 9. This is 16. Okay. Fine. Two-tail. And so probability of type 2 error You find a probability that you accept H naught. You'll accept H naught when your sample mean lies between 1 and 16. Given that, your alternative is correct, 15.6. Okay, so that's what you do on your calculator. Again, taking your sample size, you have to maybe do your standard deviation will be 5 divided by root 8, central limit theorem. So what will I do? NCD, lower limit 9, upper limit 16. Uh, Standard deviation 5 divided by root 8. 5 divided by root 8, correct? And your mean is 15.6. So that's 0.589. Acha, as I'm doing this video, I think of one more sum. Suppose if they give you a normal distribution, kx follows a normal distribution, correct? So the same thing, suppose they give you like mu is equal to the normal distribution with mean is mu, and your variance is, let's take the same sum, pi square. Let's take your sample size is 10, and your null hypothesis, alternative hypothesis, your null hypothesis mean is equal to 12.5, and alternative hypothesis mean is not equal to 12.5. But instead of giving you the critical region, they give you the significance level. And suppose they say significance level is 10%, and true mean is 15.6. True mean is equal to 15.6. Suppose there's some that I'm setting. So in this case, you don't know the critical region, but you know the significance level. So this is very important. They'll set a sum in context. So they are working with samples. So whenever you work with samples, your central limit theorem applies. That is always there. So now here what we have is, here we know the two-tailed test. First of all, not equal to means it's two-tailed. So you have to be careful of that. So sketch a diagram always, two-tailed test. Significance level is 10%. So you'll put 5% here and 5% here. 5% on either side, you'll put in. Correct? So middle zone will be 90%. Middle zone will be 90%. So if you want to find a probability of type 2 error, you need to know the critical values. So you need to know the critical values A and B. That's very important. So in this case, this will become a two-step process. Your first step will be you'll find a critical region. Your critical region is x is less than A or x is greater than B. So you need to find this A and B value using this mean. So I'll do inverse normal. So distribution, normal, inverse normal, because I know the left tail. The region of that is 0.05, 5% is 0.05. Standard deviation will be 5 divided by root 10. Remember, it's always the standard deviation when you enter in the calculator, since you're working with sample, will be the given standard deviation divided by root 10. Don't forget that. Root 10. Mean, use the original mean, 12.5. So that's 9.8992. Take most significant figure in the middle of a sum. Similarly, find B. So in B, I'll just simply from left, I'll make it right. Everything else remains the same, right? And it's 15.1007. So you find A and B. Now you find your type 2 error. So probability of type 2 error will be probability that your value lies between 9.8992 is less than X bar is less than 15.1007. Correct? Given that your true mean is 15.6. Now you don't use that. So for first part, we use mean as 12.5. Correct? And for the second part, you have to use mean as 15.6 and get the probable the white portion. Okay, so you do that. So you go to distribution, normal, NCD, lower limit 9.8992, upper limit 15.1007, standard deviation, and will remain what I entered earlier, 15.6, and you get your answers 0.376. So this is the third type. So this is important. So you need to know three types. So I did one tail test, I did two tail test with the critical values given. I did normal distribution when the SL is given. So from the SL, first you need to find the critical values and then use those critical values in the second part with the new mean to find the probability of type 2 error. Okay. So in this case, it's very simple. If they ask you type 1 error, it's simply the SL. So your type 1 error is 0.1. Okay. Fine. So what will happen is if you increase your type 1 error, if you decrease your type 1 error, your type 2 error will increase. If you decrease the type 1 error, means instead of 10%, if you take 5%, means your middle white region is increasing. So you can't get best of both the worlds. If you increase one error, the other will decrease. Now the same logic holds good for binomial as well. So you cannot draw a bell-shaped curve. They've given it the critical value. So what you need to do is, so instead of critical value, if they give you SL, then you have to use trial and error and get the critical value. Okay. Or you can use the inverse binomial also. Fine. Now here, you draw a box like this. Your critical region, so this is 0, this is 15. Your critical region is x is less than equal to 9, less than 9. So less than 9 means 8 and below is your critical region. So acceptance will be 9 and above. So this is the reject. So that's where it will help you. And remember, this is a discrete distribution. Okay. So fine. So what's your probability of type 2 error? Probability of acceptance, then the probability that your sample value is greater than 9 or up to 15, because obviously there's an upper limit for binomial. Given that your P is 0.5. So what you need to do is you have to use BCD. So distribution, binomial, BCD, lower limit in BCD is 9 greater than equal to 9. I could have written here 9. Upper limit is 15. Number of trials 15. Probability I have to use 0.5. I have to use the true p value. I take that and my answer is 0.304. So that's your probability of type 2 error. Poisson, same way. So you draw a box, correct? So your critical values greater than equal to 5. So anything greater than equal to 5, greater than or equal to 5, correct? Is your critical value. So that means your acceptance will be less than equal to 4. So this is your accept H naught, correct? This is your reject H naught. So if they ask you type 1 error, you find a black region with lambda is 2. If they ask you type 2 error, you find the white region with lambda with your lambda is 6. So type 2 error, so probably that you do your x as less than 4, given that lambda is equal to 6. So that's it. You do your Poisson distribution, Poisson, PCD, lower 0, upper 4, correct? Lambda 6, 0.285. So that's it for type 2 error. I hope you understand it. And this is how you need to find your type 2 error.